Hello everyone, welcome back to the Great IT Architecture channel. My name is Vitalii Andrusishyn, and today we are diving into fascinating realm of solution architecture, graph databases. If you're curious about how graph databases plays a pivotal role in solving complex relationships and network-related challenges, you're in for a treat. Let's explore the world of graph databases in solution architecture. First thing first, what exactly are graph databases? Unlike traditional relational databases, graph databases are designed to handle and represent complex relationships and connections. Graph DBs use nodes, edges, also termed as graphs or relationships, and properties associated to nodes. Also, this kind of DBs have a process with name and traversal that refers to the process of navigating through the graph to discover relationships and patterns. All these elements form the mechanism to model and store data, making them particularly powerful in scenarios where relationships are the key. Now, let's discuss the role of graph databases in solution architecture. In many real-world scenarios, data is inherently connected. Whether it's social networks, supply chain logistics, or fraud detection, understanding relationships is crucial. Graph databases excel in capturing and querying those intricate relationships, providing a more efficient and intuitive way to represent complex data structures. Graph databases are particularly useful in scenarios where relationships between data points are essential. Let's explore some comparing use cases of graph databases. Social networks, modeling friendships, followers, and interaction between users. Recommendation systems, analyzing relationships between users and their preferences. Fraud detection, identifying patterns and connections in financial transactions. Supply chain management, tracking dependencies and relationships in the supply chain. Network and IT operations, representing the connections between devices in the network. Now, for some best practices in graph databases implementation. Firstly, understand your data model thoroughly. Define nodes, relationships, and properties carefully based on the specific use case. Efficient querying is a trait of graph databases, but a well-designed data model is essential for optimal performance. We have most popular graph DBs for the current moment, Neo4j, and all of the most popular clouds have their own graph DB services. AWS has Neptune, Azure has Cosmos DB, and GCP has Firestore and Spanner. Scalability and performance are critical considerations. They depend on how your DB was designed. As your dataset grows, ensure that your graph database can scale horizontally and handle increased loads. Additionally, optimize queries for performance. Understand the patterns of data assets in your use case and structure your queries accordingly. You should review them periodically. This is key to unlock the full potential of graph databases. Otherwise, performance and scalability of your wrong-designed graph DB could be worse than well-designed regular relation DB. Integration with existing systems is another important aspect. Graph databases can complement traditional databases. Use them where relationships and connections are central, and seamlessly integrate them into your overall solution architecture. This approach allows you to leverage the strengths of different database models for maximum efficiency. As we wrap up, the use of graph databases in solution architecture brings a new dimension to handle complex relationships and networks. If you found this information helpful, hit a like button and be sure to subscribe for more insights into building the great IT architecture. Thanks for watching, and I'll catch you in the next video.